Okay. All right, so we're up to this part of the question. Sorry, just move that out of the way. So it is thought that the relationship between final grade and attendance could be nonlinear, and they want us to do a log transformation. What I'm actually going to do is I'm going to step you through like we would do if we weren't told which one. We're going to go through the whole process. So the first thing you would do is you got to type in those lists. So I called mine attendant, and I just called it a 10, and then the final grade. Okay, so we typed them all in. So let's go have a look. They said that if you were like doing this normally, so we said here's attendance, here's the final grade, that's the scatter plot. So they think that it's nonlinear. They're saying it tends, and you can see there is a bit of a curve there, so it probably is. So let's go check the residual plot to make sure it's nonlinear. So we have to put the regression line on our scatter plot first, and we do it like that. Once we've done that, we are able to get our residual plot. So here we go. There's our residual plot. Now, you can see this is sort of like a dome shape going on there. See how it's sort of like an arch? So that's a pattern. So if there's a pattern in your residual plot, we say the data is non-linear. So that makes sense, which is why they're asking us to transform it. So what you would be doing is here, you would be looking at your original scatter plot, which I know I'm just going to quickly draw it again here. So you look at your original one and look at your circle diagram for transformation. Which part of the circle is it? And I believe it's the top left-hand corner. So the appropriate transformations for that part of the circle would be to do the log of attendance. So I might call log attendance. I'll just call it log at. Another one is, I think, attendance squared. Is that right? Attendance squared. An x squared is another appropriate transformation. And another one that it suggests is the reciprocal of x, which means 1 over x. So I'll just write reciprocal of attendance. Okay. All right. So they're the ones that are appropriate. So what we're going to do, I might start off with, I'm not going to do the one they picked because it's probably going to be the best one. I'm going to start with this one. So first of all, if I want to do a reciprocal of attendance, a transformation, I'm going to have to create that list. So I've called it that reciprocal. And then underneath, remember, we go into the formula part and we write equals. Now, I want the 1 over, so I want that fraction template. I put a 1 on the top. And down the bottom, I have to put my attendance, whatever I called it. And I called it attend, so I'll do that. And that creates that list. Later on, when we go to do the squared transformation, we will go under here, we go under equals. We write our attend list again, but this time I square it. And there you go, there's that list is already in the calculator. And then log is another one they want me to do. So if I go equals, remember, we get the log function up. It's always 10, log 10. And then in those brackets, I put whatever list I want to log, which is an X one. All right, so we do that. So let's test. What I'm going to do is test the first transformation that I did, which was reciprocal A. So attendance. So here, that was that one. I didn't change the Y, so it's still final grade. If you have a look at that, to me, even though this is transformed, it still looks a little bit curvy. This is why you must check the residual plot. So I'm going to go check that again. So I'm checking the residual plot of my transform data. So I go analyze regression. I've got to put that on there. Then I go and get the residual plot. So we get the residual plot. And to me, there's a pattern there. Can you see? It sort of looks like it's all gone down in a U. That's too much. It's not random. There's too much of a pattern there. So that transformation was non-linear. It still hasn't straightened it up. So we would not be using, that would not be a good one to use. Okay, then I'm going to try the other one, I'm going to graph the other one. So the other one that we had was squared, attendance squared. Ooh, what happened there? Attendance squared and final grade. So if you look there, does that look straight? That does not look straight either. So when I go and check the residual plot, I'm thinking I'm going to get another pattern. So this, if we have a look, show residual plot. Yep, see we're getting like that arch there. So that's still non-linear, which is probably why the exam chose the log one, because if we go and do the log one now, which is the one they chose, if I do log attendance, final grade, that's starting to look very straight. And so if we go and do the analyze, regression, a plus bx, and then I check the residual plot. Oh, what am I doing? Analyze, residual plot. We're going to see, now this is random. So this one is linear, which means it's a good transformation, and then I can use that one. You got a question, Charles? Yep. So now we've done that. So what happens is, in the exam, you're asked to get all the equations of the transformations. So when you do that, you still do it the same way. Stat calculations, you go to a plus bx. Say I want the log transformation. I logged the attendance, and then I also just used the y. You just put the right lists in, and then you've got your equation, and you'd be writing it out. You'd write final grade equals, and we write negative 64.7 plus 75.4, because I think the original one said to do the 3 significant figures. So we could pop that in there. Now it says use the equation to predict someone who attends at the 95. So that's where you have to be careful. When we have it transformed, it's probably best to use the solve. And we'd go solve, and we say final grade equals, I forget what we said the values were, 64.7 or negative 64. So negative 64.7 plus, what was that, 75.4, and then we're going to go times. Now it's the log 10 of attendance, I think it said 95, sorry, I couldn't remember. Attendance 95, out here, comma F, that person who attended 95 got an 84%, that was the predicted, okay? So there's the us doing that prediction. All right. So if more than one transformation produced linear, you then go to the R squared to pick which one's best. All right, just going to stop my video.